Smart Textiles, Smarter World. Spark innovation with the SmartX community.
So we are here at Techtextil and we are taking the opportunity with this exhibition to have interviews with different members. And we are here with Steliyan from 3E Solutions. We're going to go through embroidery and how we can apply Smart Textiles within embroidery. So, floor is yours.
Yeah, so hello, my name is Steliyan and I am a co-founder and development engineer in 3E Smart Solutions. So now we are at the booth of ZSK Embroidery Machines, which is focused on technical embroidery. So this is on the one hand side our composites department with our internal engineering office Online 3D and our Smart Textiles department with the internal engineering office of 3E Smart Solutions. So we'll be making a tour on our stand, showing you some of our functional demonstrators, and then show you the machines and the embroidery technology for integration of smart e-textiles.
With the demonstrators, we're going to see a few of them. So where do you want to start?
Yes, so we start with the one of the main technologies that we use. It's the integration of PCB. They can be rigid or flex, and they can be placed automatically by the embroidery machine. So here you can see a demonstrator that we call Pinch Me, which has control elements leading to a blinking of an LED in different colors. And this whole sample was made fully automatically by the machine using the PCB placement device.
So you will basically program the machine to follow the, along the drawing where the PCBs and then it's
exactly.
One more go without.
Yes, we create the design. Of course, it has to be tested so that everything is okay, and then you just press the start button and you have your finished. So moving to the next one. Here we are showing the partly encapsulation of PCB boards to protect sensible components while still leaving the connection elements free of coating so that we're able to do the embroidered connections. We're using a silver-coated polyamide thread for this one, but we are pretty flexible to use other materials as well.
Good to know. And what do we have here?
Here we have an example of a circuit containing LEDs that were placed automatically by the machine and capacitive sensors, where we would like to show that capacitive sensors function even through different materials. So they can be covered by dielectric materials like leather, wood, or plastic, which is a good example for the automotive industry who like to hide the functional components under a beautiful interior layer.
And for example, because this one you told me that it could be for automotive because it's like tactile, let's say it like that. But those other demonstrators, they are as well for automotive, and you can apply them for automotive. Or you have any other applications that came to your mind?
Well, you can apply them in all kinds of industries, also in medical, sports. So if you want to acquire body signals or to use stimulation, we'll move later to the next technology, which are the textile electrodes. But yeah, basically you can use them in all different areas, even in fashion or protective wear. This is one of our most fun demonstrators.
I guess it's the same technology? Or,
Here again, we have capacitive sensors, but as you can see, this is just an off-the-shelf PCB board, whereas the other PCBs were designed specifically for embroidery.
And here for the, I guess everything is connected because if it's for automotive, but how do you deal with energy harvesting? Because of course, if it is a wearable, you need to.
Yes, so here for the demonstration, of course, we use some ordinary USB cables, but most of these applications would also work just from a coin cell battery, so pretty compact.
And I don't know if you test anything for washability.
We have done washing tests with our PCBs that are embroidered, So the focus was not on the PCB itself, because the PCBs can be coated and that's all fine. We wanted to test the reliability of the embroidered connections. And we did 50 washing cycles and the connections was still okay. So we can say that our embroidered connections are washable and without the need of any gluing or soldering.
Okay, so next demonstrator.
So we are moving to the second technology, which is the so-called moss embroidery that we use to create electrodes that are very well suitable for medical, wellness, fitness applications, both to acquire body signals, but also for therapy in terms of muscle or nerve stimulation, like in this EMS belt that you see. So if you like, you can try our demonstrator. Just place your hands and it will measure your heart rate. We can use different materials as well, so we can achieve different haptics depending on the application, like from very soft that we use for babies or infants. We have some middle roughness for adults, and we also have really rough electrodes that also work for the veterinary field.
Okay. So for dogs and
Dogs,
animals,
horses.
horses. Okay. Yeah. I mean, here we can see. I mean, if you grab the latch, you see that this one it's not so pleasant as if you touch that one.
Exactly. So we also use this haptics difference to create sensors that you can basically feel without having to look at them. So if you imagine a car seat with integrated embroidered sensors for seat adjustment, you don't want to look at the sensor while driving, so you can just feel where is it.
And this is why you are like using different shapes.
Exactly, different shapes, field or not field, and different materials. So it's pretty intuitive to see the difference.
And here, that's for electrostimulation.
Exactly. This is a kidney belt or for low back pain relief. It uses electrical impulses and again the embroidered electrodes to conduct the electricity to the body.
And for example, is that we see that it's a BL demo or any of these prototypes already being sold. So
I would say they're currently in development.
okay.
So the projects are currently running. Of course, for medical applications, they take a little bit longer. But there is a lot of interest, and there are some extensive tests that are being done with the electrodes. And we hope that in the near future we see a product in the market.
No, because I think it will be helpful. I mean, it's not the same like to wear something than maybe to produce something for your body. So for monitoring, and that you can walk. I mean, if you are monitoring with one wearable device, you are walking outside, and when you don't need it, you remove it. So it's quite comfortable.
Exactly. It's very comfortable for long-term applications because it doesn't need any gel or moisture in most applications. So easy to use.
It's interesting. And what challenges are you? Because I mean, you have the machinery as well. So what challenges do you face when scaling one of these prototypes?
Well, scaling is pretty easy with embroidery because everything that can be done on a one-head embroidery machine can easily be scaled up to like a 20-head embroidery machine. So that's not really an issue. But what we would like, we are very open for new materials that we can use with the embroidery machines that probably have higher conductivity or some better chemical durability. So the third technology is related to the tailored placement of fibers, wires, and tubes, the so-called TFP, tailored fiber placement. And here we can see some examples that are, for example, used for heating applications. We have a heated kidney belt. The same technology is used in most of the car seat heaters as well, also integrating capacitive occupancy sensors. And it can be also used for more decorative applications, like the placement of optical fibers or an LED wire, also in a more flexible manner.
Because it's not even like broken or tightened, so you can really strengthen as much as you want.
Yeah, well, we use structural stretchability, so we lay the fiber in a certain shape to allow for a stretchability together with the carrier material.
And have you, apart from the heating, I guess the lighting applications is for protection and fashion as well.
Exactly, fashion and protection equipment.
Okay. So interesting. So let's going to see now what machines you use for that technologies.
Yeah, this is a JGW machine from ZSK. It is used in this case for carbon and wire laying at the same time. So we have a twin supply system. So you are able to have two different materials that are fed to the needle. And we have an automated changing device that can switch between the different materials.
So, the two different materials, they are connected to the same needle. Is what I know.
With this technology, the materials do not go through the needle. They're fed down by a feeder,
Okay.
and then the needle would embroider left and right from the material to fix it down to the textile.
Interesting.
And in this case, we combine a composite material, therefore the carbon fiber, with a heating functionality. So basically creating smart composites.